All right, Algebra 2. So I have an appointment today and I cannot be in class, so I'm leaving you some notes on graphing logs. Okay, so a lot of this we've talked about before, so hopefully this will feel very comfortable. All right, so we see that we're going to contrast the exponential function to the log function. And the biggest point of reference is your asymptote. We know that for logs, right? The asymptote is y equals k. Y equals k. And we also want to, pin down there, we also want to pay attention to the fact that um, the b values, right? B greater than 1, we know this is growth. Okay, so we've got b greater than 1, b between 0 and 1. So we see that we have growth. We don't really think of logs as growth, but they are growth. And this is decay. Okay, so now the difference between exponential functions and logs is that logs have a vertical asymptote. Vertical asymptote. Okay, which has a total change of domain, you see. So the the logs are always to the right of the asymptote. Um, and we see that the domain of the exponential function is always all real numbers. And then the range, right, has to do with y. Like it's either y greater than k or y less than k. Okay? Whereas with a log function, your domain is not all real numbers. First of all, let's say this. This asymptote is x equals h. X equals h. Okay, because the graph shifts left, right, with h, and that's what determines our vertical asymptote. So when we're talking about domain and range, the domain is going to be x is greater than h. That's what it's always going to be. I mean, you can shift it to the other side, but we're not going to do that this year. So our domain is going to be x greater than h. Our range, though, okay, if you think about the little arrows on here, right, our range is all real numbers. And this makes sense with the properties of inverses, right? The domain of the original becomes the range of the inverse. Okay, the range of the original becomes the domain of the inverse. So one of the things that is not pictured here, that I just want you to, I'm not going to draw it on there to make it too visually busy, but all of these pictures are picturing a greater than 1. So there is also the idea that, as we've known with growth, this is growth. It's either positive growth, or flip it over that asymptote, negative growth. This is positive decay. If I flip it over the asymptote, that shape would be negative decay of an exponential, which looks so much like a log, right? So the clarifying feature is the asymptote, okay? And this function is a positive log with a b value greater than 1. But if it's negative, if the a is negative, it would flip and it would look like that, right? Which would look like the negative, would look like the decay function. So these get a little confusing. We'll try not to be too complicated, but just know that, keep that in mind. Okay, so state the domain and range of the transformed functions. So we have said for logarithms. Now we're focusing on logs. The domain is x greater than h, or soft bracket. Soft bracket, h to positive infinity, right? It's soft bracket because this is an asymptote. The range for the log is going to be all real numbers. Always all real numbers. The asymptote of the transformed function is x equals h. That's big. Okay, we're going to consider this log. Whenever you're looking at a log, you think A, H, K. And we see that A is 1. We see that H is -3. We see that K is +2. So when we're talking about transformations, there is no transformation according to A. This is left 3, and this is up 2. Okay, and so this graph has shifted left 3, up 2 with no A shift. Okay, so if this is the case, then my domain has to do with H, right? It's soft bracket, -3 to +infinity. This graph exists for which x values? Above -3 to +infinity. Range all real numbers. Write the equation of the asymptote. X equals -3. Vertical asymptote. Okay? So those are kind of the real quick overview of the graph. We're going to get into the nitty-gritty. Let's flip the paper. Which of the following statements are true about the log function below? So this is A is 1, H is -2, K is -3. So the domain is x greater than 2. Is that H? Well, this would be false, right? Because it's x greater, so my domain is x greater than -2. All right, range. Why? We know that's not true, right? The range is all real numbers. This is false. The range is all real numbers. X-intercept occurs at 998, 0. Well, the x-intercept is going to occur when y is 0, so I could solve that. On a calculator, I could solve it by saying y equals 0 equals the log of x plus 2 minus 3. I could plug that into the calculator and find the intercept. I could solve it, but I don't want to get into solving because we haven't done that yet. So let's leave that for now. We could put it into a calculator. In fact, I will do that. Okay, so of course, general graphing you have to do without a calculator, but I won't ask you for the x-asymptote. Y equals, okay, the log, well, it is the log base 10, isn't it? So I can just hit log, and then x plus 2 minus 3. And now I can go to the table, or I can go to the graph. I want when y is 0, so let's go to the table. And we see that, let's look and see if we can see y is 0. Oh yeah, if I'm trying to get to y is 0, then that's going to be hard to see. Let's see the graph. Zoom. 6 gets me back to the 10 by 10 window. X-intercept is going to occur way later, and I will have to solve that. So let's not do that now. Okay, y-intercept. Now, the y-intercept occurs when x is 0. So I can solve for that, right? When x is 0. Y equals the log of 2 minus 3. Okay, and if I put that in a calculator, I could find that. I could also do second calc value, x equals 0, and I will get negative 2.698. Okay, so that is true. And then there is a vertical asymptote at x equals 2. This is false, right? Because we already said the vertical asymptote. This is false. The asymptote is going to be x equals negative 2. Okay, let's match the functions. So the first thing to do is asymptotes. X equals 0. Asymptote. X equals negative 1. Asymptote. X equals positive 1. And so that is really easy to see. Here we have a positive 1, right? Because it's x minus positive h. H is positive 1. Here h is 0. H equals 0. And here h equals negative 1. H equals negative 1. X minus a negative 1, right? So this is going to be I. H is 0 is going to be, I'm sorry, this is going to be I. I'm reading. This is negative 1, so it's here, double I. This is H is positive 1, so that's going to be triple, Roman numeral triple I. Okay, now let's get into some nitty gritty of our graphs. Okay, so we have a basic log function when A is 1. Okay, so let's make a note of that. A equals 1. We see also, just while we're at it, H is negative 3 and K is positive 5. So when we graph logs, we are going to graph the parent and then we're going to shift according to H and K. Okay, so the parent is, remember, H equals 1, H equals 0, K equals 0, A equals 1. Okay, so that's going to be y equals, A is 1, log base 2 of x. We see that H equals negative 3, so that's going to be a left 3 shift. We see that K equals 5, that's going to be an up 5 shift. All right, now here's the trick with graphing log functions. Okay, let's write our parent. We have y equals the log base 2 of x. But in order to get values, because this is the inverse, we input y values, okay? And then we solve for our x values. So we need to rewrite this as an exponent, which we know we learned how to do yesterday. So let's do that. Let's do our arrows. Start at the base. 2 to the power of y equals x. Let's write it down. 2 to the power of y equals x. So now I've got the inverse of the log. It's the same function, but now I can plug in y values and get my x values so I can plot this graph. Okay, so let's do some math. When I plug in the y value, right, I'm going to get 2 to the negative 3, right? I'm plugging in negative 3. Well, that's going to be 1 over 2 cubed, which is 1/8. Okay, and I'm going to plug in 2 to the negative 2, 2 to the negative 2, which is going to be 1/4, right? 1 over 2 to the positive 2, which is 1/4. Plugging in negative 1, that's going to be 1/2. Plugging in 0, that's going to be 1. 2 to the first, 2. 2 squared, 4. 3 squared, 8. Okay, let's plot the parent. Now we are the parent. Okay, so the first thing I'm going to do is graph my asymptote. Okay, so my asymptote is x equals, go back up and get it, negative 3. X equals h. That's my asymptote. So I'm going to graph my asymptote. And I'm going to label it x equals negative 3. And now I'm going to plot my points. Okay, again, this is the parent. I'll do it in pink. And I have negative 3. This point is x is negative, x is 1/8. I was doing it backwards. Okay, x is 1/8. So here is x is 1/8, right? And then my graph is at negative 3. So that's going to be down here. This is the parent. Oh, so that's going to be the real asymptote. Here's my parent asymptote. Sorry, guys. I'll do that in orange. So that's my parent asymptote. Notice, what is the asymptote here? This parent asymptote is x equals 0. So this is the parent asymptote. And let's label it parent asymptote. Okay, and we're graphing these points. Okay, so we've got 1/8, -3. Then we've got 1/4. We go over a little more, -2. Then we've got 1/2, -1. Then we've got 1, 0, right? 1, 0, there it is. Then we've got 2, 1, 2, 1, 4, 2, 3, I'm sorry, 4, 2, 8, 3, 8, 3. Okay, so this graph right here is, let's write along it. This is the parent. Okay, this was the y equals the log base 2 of x. Okay, so that is a fairly easy graph to do. Now, but I do have to shift it. So let's shift it. So I'm going to shift this graph and I apply my shifts. Right? My shifts are left 3, up 5. A has no shifts. And actually, we're going to do that next. If we have a value of A, we plot the points for the parent with A. Then we shift according to H and K. So now we're going to take these points. Let's start with the easiest point. We have the point 1, 0. I'm going to shift it left 3. 1, 2, 3, and up 5. 1, 2, 3, 4, 5. Okay, let's take this next point, which is at 2, 1. Shift it left 3. 1, 2, 3, up 5. 1, 2, 3, 4, 5. Let's take one more point. Let's take this point at 4, 2 and shift it left 3. 1, 2, 3. 1, 2, 3, 4, up 5. Now, all you need is 3 points and an asymptote to graph the function, right? Because this function goes up this behavior, right? And then it approaches the asymptote. So this is the graph of the original function f of x, okay? Which is shifted graph, the log base 2 of x plus 3 plus 5. Okay, let's write that. That is up above y f of x equals the log base 2 of x plus 3 plus 5. And that is how you graph when a equals 1. Now, let's flip you can, if you guys want to pause the video, you can, and just finish that up. Let's flip it over. And now what do we do when a is greater than 1? Okay, and we're going to start the same process. The parent along with a. So the parent with a is y equals 2 log base 3 of x. Now, h and k. So we see that we have h equals -4. That is going to be a left 4 shift. We have k equals -1. That's going to be a down 1 shift. Okay? So we are going to graph the parent with a in our table and then shift every point left 4 down 1. So let's go up here and we've got y equals 2 log base 3 of x. Well, there is a property of logs that tells us that we can move this 2 that's multiplied out here to become x squared. So when we have a, we first move this coefficient out front up here. I'm going to make that clear. We've got y equals the log base 3 of x squared. Okay? Now, we're going to rewrite this function. And we're going to say, start with base 3 to the power of y equals x squared. Let's go do that. So we're going here now. we've got 3 to the power of y equals x squared. Now we still need to solve for x, right? Because we need to plug in y's to get x's. So we do one more step here. We take the square root and we get x equals the square root of 3 to the power of y. So this is what we are going to plot into our table. Okay, so let's just review what we just did. We had the parent function. We moved the number, the a value here. Okay, then we rewrote the function as an exponent and we solved for x. And now it's going to be the same as the problem before. Okay, we're going to do some little math here without a calculator. And so, as I'm plugging in -3, so let's plug in -3. We've got x equals the square root of 3 to the -3, which is the square root. Now 3 to the -3 is 1 over 27. Let's write that up there. The square root of 1 over 27, which is not easy for me to do, so I'm actually not going to plot that point. Okay, let's do number 2. We're going to do x equals I'm just doing this function right here, the square root of 3 to the -2, which is the square root of 1 over 9, which I can do. Okay, so now I'm going to put that in a different color, right? The square root of 1/9 equals 1/3. I'm going to plot that point. Let's do the next one. I'm going to do x equals the square root of 3 to the -1, right? Which is the square root of 1/3, which I can't do without a calculator, so I'm not going to. Here we've got the square root of 3 to the 0, which is the square root of 1, which I can do. So I do 1. And then I've got the square root of 3 to the 1st, which is the square root of 3, which I could kind of plot, but I really don't have the definite answer there. I only need 3 points. So then I've got the square root of 3 squared, which is the square root of 9, which I can do, which equals 3. Okay, so I've got the 3 points that I need. And eventually, as you become familiar with this, and you're looking at this function, you actually just choose x values. Like if I were looking at this function and I knew I had to take a square root, I would only choose x values, right, that I knew I could take the square root of. 3 squared is 9. 3 to the 0 is 1. And I would only choose the easy, doable x values. So with this function, that's how we do it. All right. So we're going to graph the parent. This graph is going to go with this. Okay, so we're going to graph here. So let's graph the parent. I'm going to graph the parent in orange. And this is the parent, and I've got 3 points. And so I'm here, I've got x is 1/3, and this is where it's kind of a little bit mind-bending. X is 1/3, so I have 1/3, and I'm going to do down -2. There's my first point. Then I'm going to go to my next point. X is 1, 0, and then 3, 2. X is 3, y is 2. So this is the parent, right? And the parent asymptote is x equals 0. And I'm not going to draw it, but I'm going to write parent here. And now I'm ready to shift my graph according to H and K, right? Left 4, down 1. So let's do that. So I'm going to take this graph and I'm going to shift it left 4. So start with this key point, 1, 0. 1, 2, 3, 4, down 1. Right there. There's my first point. Now let's take this point and shift it left 4. 1, 2, 3, 4, down 1. Let's take this point, which is 1/3 -2, and shift it left 4. 1, 2, 3, 4, down 1. Right? And I've shifted my graph. And now, before I draw, I need that asymptote. My asymptote is x equals h, right? H is -4. X equals -4. So let's draw that. Okay, so we've got carefully drawn and labeled x equals -4. Now I'm ready to draw my graph f of x. Here we go. Okay, there it is. Approaching the asymptote, this is the graph of f of x equals 2 log base 3 of x plus 4 minus 1. Okay, so parent with a, move the a, rewrite the exponent, rewrite as an exponent, solve for x, plug into your table only values that you can do by hand. Like, you don't have to make equal. You can try it on this table, but you can choose the values that you know are going to be square rootable, okay? Or cube rootable, depending on your new problem. Okay, so what I want you to do is I want you to try this problem. The key will be there, and you guys can check that. Okay? All right. Do your best. There's practice, and you can write down your questions, and I will be there next class. All right, guys. Have a great weekend and a day off.